Hello, in this video, we, I'm going to talk about light, a little bit about our history on light. Where Galileo tried to measure the speed of light in his time, uh, he said it was too fast to measure. Uh, his ideas in the universe mechanics, let's say, come from Aristotle that talked about the good life. But it was Galileo, I believe, that mentioned uh, the speed of light. Uh, Isaac Newton does not talk about the speed of light. I think that's why Einstein decided that light was important because it was a velocity that was fast, even though they didn't measurement. So in his time, Mitchell and Morley and stuff, they wanted to measure exactly what the speed of light was. So with Einstein's employment at the clerk's office, where he read patents in scientific equations and theory, that only created greater knowledge of what physics was. So finally, afterwards, he wrote his two books, CRT, Special Relativity Theory, and 10 years later after that, GRT, General Relativity. So the speed of light at that time is the fastest known element, let's say. I don't even think it's an element. It's more of a property because it has no mass, which means that it's like midfield, a source that will reflect and create light, like a lamp or a light bulb, and correlate light throughout the universe, from the suns. But anyways, I just wanted to put that in there because I was wondering where Einstein got his idea about his light constant. So, what's the universal speed limit? Now, Isaac Newton did talk about, even though he didn't talk about light, he had a universal gravity, which means he didn't talk about light as any type of constant. And I guess Einstein believed that maybe we should put it in there. And so he proceeded to publish his books about light. Now, today's science, we believe it to be something else other than light. That it's a speed limit in which he claimed that governed the universe. Nothing can go faster than the speed of light. And so any velocity between 0 and the speed of light is irrelevant. And then what would happen after, if he did reach the speed of light, he wrote that we would go in a mode of time travel, some type of mode. That if we continue to travel at 196,000 miles a second, we would travel into the future. If we went faster than light, we would go back in time. And he wrote a mathematical formula for that. That if you travel at the speed of light for an hour, you would go 80 years into the future. So we are caught in a science that later, even though it was later, discovered that the universe was expanding, which upset relativity, which Einstein preserved to say that it's the biggest mistake he made in his life. I don't think maybe it's any type of mistake, but it's in literature and it's taught in universities. We are limited to the speed of light. I don't know what other sciences in the universities are taught, but Einstein's theory was only 100 pages. I think GRT was 100 pages. Or what, maybe it was special relativity was 100. General relativity was like 120 pages. And it goes into his ideas about what he learned at the patent office, those theories that he read, he learned from. But anyways, expanse takes us out of the speed limit. It gives us another speed limit, which is kind of sad to say because that speed limit means that as long as the universe keeps expanding, the speed limit will change over time. That's the Hubble universe. Expanse, space expanse is notification of the books that I've been writing about. How even at a young person, I believe that if space was a vacuum, that it had zero mass. And it does. It's zero. It's a zero vacuum. So anything related to the speed of light or a zero vacuum can be said to be exempt from the sciences or my sciences. What I mean by that is there are new theories that have been developed to try to change the speed of light. Bending space was one, the Rosenberg Bridge, another Alcubierre warp drive is another. But now, with expanse, we know that the universe is in a constant revolution of change. That the pressure, or that it's pressure that is creating the expanse. And we know this because Edwin Hubble measured the galaxies being separated at a certain velocity or rate of velocity, 43 miles a second. Every second. And so the evolution of future science is expanse. The literature that they talk about in university, classical physics, modern physics, ancient physics, reached a point to where they believed to be a speed limit. Now, Galileo didn't say that the universe is limited. He believed that it was the fastest thing that they knew at the time. a physical explanation about the universe didn't exist, and it still actually does not exist. We cannot say for sure that our theoretical ideas are reality. But they are there and they have been measured. So, I would like to say one thing, that in relativity, it seems that the earth science and gravity has been exported to space to having the same effects. And that just can't be true. Because on Earth, gravity is 9.8 meters a second, which is equal to about 1 mile a second. And space is a zero vacuum, retains no energy. In relativity, matter retains all the energy. Light has zero mass, so it has no real energy. It's made up of photons, which are weightless, let's say, and have a specific velocity. But that doesn't mean that the universe is governed by that velocity, as Einstein did. But it's probably believable in those times. Expanse is a theory that illustrates how much energy or pressure in space that is being manipulated by a growing anomaly. That anomaly has been described by Edwin Hubble as some sort of sphere or balloon that is continually getting larger and larger and changing how much pressure it puts out into the space. We're talking about empty space. We're not talking about the gravity that exists in a planet's atmosphere, any planet's atmosphere. We're talking about that dark matter that seems to be continuous. It's, as long as the anomaly keeps expanding, the galaxies that surround this anomaly and that are getting affected by it, shown as a force of forcing the galaxies to separate, whether it's one, two, or all of them, is creating a path of space between those galaxies. A path of space that is a push force or repulsive force from the growth of the anomaly. What exists outside the galaxies is more empty space, dark space, or deep space, you might call it. And how much there is of this deep space that this anomaly is creating pressure and pushing the galaxies towards is unknown. Some call it nothingness. It's nothingness. And you wonder what space is. What is space? Empty space. I don't know what the exact, as a field, I don't know if exact explanation or definition of that type of field would be, except nothingness. And we are the material universe, the Hubble universe, that it is expanding into. So there's more space out there. And what the reason or the natural theory is about this is unknown. There's always going to be something unknown. Exactly how the Hubble sphere works, or we know how it works, but what it is probably beyond our reasoning, except for what Hubble come up with and the expanse of it. But I wrote a book. I've written several books, but one of them was "We Should Live in a Black Hole," or "Why Doesn't the Universe Have a Black Have a Black Hole? It Should," or something like that. It's one of my books where I explained that things, since they spin, talking about how fast they can spin, and we have the idea of what vortexes are. And so how did this anomaly come in the picture? You know, something relative to a anomaly that's blocking the universe from being sucked into a black hole, a large black hole where this anomaly formed against the will of the black hole, and it's plugging it up. And so we're expanding rather than being sucked into it. Now everything knows that space seems to suck things out. It sucks the energy out of people. It sucks the life out of life. And that seems to be what a black hole does, but for some reason we're in our universe is in an expanse. It's not the universe and material things, matter, galaxies, planets that are being duplicated, or not duplicated, but being born more of, to compare why we need more space. It's this anomaly that is pushing us and creating a repulsive pressure force in the space that all our universe planetary bodies live in, large and small. Where life comes in, this I can't say, but I know there's other books on that. But that's my short lecture on what expanse is and where I think Einstein got his idea on a speed limit, and where it was going when he worked in the patent office. Thank you.